Okay, so in this video, let's talk about the benzene and its reaction. So first reaction which we are going to talk about is the formation of chlorobenzene. Here we are going to add the chlorine into our benzene ring, right? So normally the benzene is a very stable structure. So we need a catalyst. So you need either aluminum chloride or ferric. So either one of these is fine. You can do the reaction with it. So let's look at the mechanism, how this reaction proceed in our organic reactions, right? So at the first, what happens is here we have the AlCl3. Okay, I'm going to go through with AlCl3, right? It's same with the FeCl3 also, right? So here you have the AlCl3 and here you have the chlorine. Now these chlorine atoms has electron lone pairs. One of these electron lone pairs will go and attack to our aluminium center, because with these chlorines, with these chlorine atoms, these are electronegative, so these will pull electron density out from your aluminium center, right, which make it little bit electrophilic, right? So this nucleophilic lone pairs can go and attack to our aluminium center. Now we will have the product like this. So just let me put the normal arrow. Okay, we have the product like this: half formed bond between the chlorine and aluminium, and half broken bond between the chlorine and chlorine, right? This is our product. And then what happens is, now benzene comes into the place. So let me take another color to draw the benzene. Okay, here we have the benzene. Okay, now 1 2 3. So this benzene rings has higher electron density, right? So these benzenes can act as nucleophiles. So due to this bond formation, right, due to this bond formation, this chlorine becomes much more delta plus, because like this bond is going to be broken, right? This bond is going to be broken. With this broken bond, one of the electrons of this particular chlorine is going to be going away. Due to this, due to that effect, this chlorine is going to be a positive charge, but still it's not a positive charge. With the time, it is going to become a positive charge. So we can indicate it's relatively little bit electrophilic. Now this electron pair will go and attack to our chlorine. Due to this attack, this bond will be broken away. Now we will have our structure like this with our benzene. Now this double bond is not on the same position, right? This double bond is broken, right? This bond has broken and formed a new bond with our chlorine. So here we have our chlorine, and also don't forget there's a hydrogen in this particular position too, right? This is the newly formed bond between our chlorine and benzene. So now there's no bond here, but there are two bonds on these two places. If you look closely, when this bond is going to be broken, this carbon, right, this carbon has a problem. Initially it has no problem, it's stable with 4 bonds, 1 2 3, and there's a hydrogen 4, but now it has only 3 bonds, so it becomes positive. Due to this positiveness, we can draw resonance structures by this bond is going this way, so I can draw resonance structure like this. So now the positive charge is here. Here you have the chlorine and hydrogen. Let me take it to the next page. Okay, so here you have the chlorine, here you have the hydrogen. So initially, like, it was like this, no? Okay, so resonance structures is forming. This is the same structure, right? This is the same structure which I have drawn here. So I just wanted to take it on the same page, right? Okay, here now we have the second structure. Now positive charge is here. and now this one can move into this place. Now we have our positive structure in here, chlorine, and here we have the hydrogen. Okay, now look at this. There's a positive charge in here, so this positive charge can be neutralized with the breaking of this hydrogen carbon bond. So there can be a water molecule here. This water molecule can go and attack to this particular hydrogen to break this particular bond. So now we have this kind of structure. We have original benzene ring, aromatic ring is formed with the chlorine in it. The hydrogen is broken away, and don't forget we have a AlCl4, right, minus. So now these two, this H plus or this hydronium and this AlCl4 minus, this can react together to form back the AlCl3 and HCl. So we have our final product. This is our chlorobenzene. This is our chlorobenzene. So like there are some few important points which I need to highlight about. Look at the difference of these steps, right? Here I have denoted the arrow. So this is wrong, right? There should be an arrow. So if you know about more advanced organic chemistry, this double arrow, this means the retrosynthesis, right? Retrosynthesis step. This is mean the retrosynthesis step. We will talk about it in our next further videos. So in a normal reaction mechanism, a step is represented by a single arrow, right? This is a double head arrow, right? You can see here. These are going to use. You can use these kind of arrows when you are representing resonance structures. So these all are resonance structures. This is not a reaction step. The same condition, the same molecule can form resonance structures with itself. So these are resonance structures. And also remember, we are telling that benzene is much stabilized, right? It's because of this resonance effect. Always remember that with the resonance effect, right? With the resonance effect, you can stabilize particular carbocation. So this particular carbocation is relatively stable. This particular carbocation is relatively stable because it can distribute its positive charge along its molecule. You can see there are three possibilities, right? It can be either here, here, here. There are three possibilities. So the positive charge is distributed. With the distribution, you can stabilize the particular carbocation. That's an important point. Now, these small things you need to remember, right, when you are drawing a mechanism. And the final thing is this AlCl3. You can see initially we have used AlCl3, and finally when the reaction is completed, you have AlCl3 as it is, right, which means AlCl3 is a catalyst, right? This is a catalyst. So AlCl3 is a catalyst, you know that, but the catalyst is, right? So normally if there's a component which is not affecting along the reaction mechanism, it is a catalyst. So I hope you got the idea about the basic reaction of chlorobenzene formation. In next video we will talk more about the benzene reactions.